So solving linear inequalities really works almost the same way as linear equations. Just a few little tricks to it. The key is where we have our inequality, we would treat that like we would our equal sign. Then we're going to simplify. If they're fractions, we'll multiply every term by the least common denominator, so that's all the same. Move the variable terms, move the constant terms. And then in this step where we're making the coefficient of 1, where we're multiplying and dividing both sides by a value, if that value that we're multiplying or dividing by is negative, then we need to flip the inequality. So we just need to be careful of that scenario. Otherwise, the inequality just stays the same throughout the whole process. And we can check the solution with these as well by just kind of choosing a value that fits and see if it works. And something we'll talk about is how to present our solutions. There'll be a few different ways. When we talked about inequalities before, we talked about the set builder notation, interval notation, and the graph. So we'll focus on the interval notation and graph portion today. So with this example, what we would do is simplify both sides of the equation. So with that, I'm going to distribute the 3. So I'll have 8x minus 4 is less than 3x minus 6. And then we're going to move our variable term to one side. So something I mentioned with linear equations is we typically move the smaller value to avoid negative numbers. I'm going to be a little tricky here and actually do the opposite so that we can see this special case that comes through. So I'm actually going to move the bigger number. So I'm going to subtract 8x from both sides. I mean, we're going to get the same answer out if we had subtracted 3x. It's not a big deal. It's more a teaching opportunity. Alright, negative 4 is less than, and that'll leave us with negative 5x minus 6. And I'm going to add 6 to both sides. So we'll have 2 is less than negative 5x. And then we want to make that coefficient of 1, so I'm going to divide both sides of the equation by that number multiplying by x. And this is where, as soon as I notice I'm dividing by a negative 5, I need to pay attention to what I do with that inequality. So mathematically, nothing's really different. The left-hand side would be negative 2/5. Right-hand side would just be x. But the direction of my inequality, where it has this less than direction before, now it's going to face the other direction. So it flipped because of that division of a negative number. If we multiply or divide with a positive number, that's totally fine. Our sign would just stay the same. But as soon as that's negative, it flips. And be careful, sometimes students make the mistake of subtraction and thinking that would flip the sign, but it doesn't. Subtraction is fine, the sign just stays the same. It's division or multiplication specifically. Alright, so what we get from this is that x is less than negative 2/5. So in interval notation, if x is less than this value, then it's going off to negative infinity, and then we'll include everything up to negative 2/5. But since we don't want to include negative 2/5, we would use parentheses. Then for a graph, what I'm going to do is grab values around that. So how about 0, negative 1, negative 2, 1, 2. And negative 2/5 is maybe about right there. And then I would use an open circle since we're not including the number of negative 2/5. And then that's going to go off to the left-hand side. Alright, let's look at a few more examples with this. So, simplifying both sides of the equation. So this first one, I'm going to distribute that negative 2. So I'll have 3x. Negative 2 times 5 is negative 10. Negative 2 times negative 2x is a positive 4x. More than or equal to negative 2 plus x. And then just combining like terms, 3x plus 4x is 7x. Minus 10, more than or equal to negative 2 plus x. Alright, I'm going to move my variable term. This time I will go with the smaller value, so I'm going to subtract x from both sides. So that'll leave me with 6x minus 10 is more than or equal to negative 2. Then I'm going to move the constant term away from my variable, so I'm going to add 10 to both sides. So 6x is more than or equal to 8. And then I'm going to divide both sides by 6. And since that's positive, I don't need to worry about changing the inequality. It just stays going the same direction. I'm just going to reduce my fraction down, so 8 over 6 is the same thing as 4/3. So x is more than or equal to 4/3. So in interval notation, that would look like starting at 4/3 and including 4/3. So we'd use a square bracket. And then we go up to positive infinity. So on a graph, I'd have, let's see, around 0, about 1, 2, 3, negative 1. So 4/3 is the same thing as 1 and 1/3. So I'll have a solid circle at 1 and 1/3, and then going off to the right towards positive infinity. All right, with fractions. So in that first step, it says that if they're fractions, we can multiply every term by the least common denominator. So again, we want to find a value that both of the denominators multiply to, and it would be nice if it's the smallest value that they both multiply to. So with 5 and 3, that's going to be 15. So we're going to multiply every term by 15. So that term will be multiplied by 15, and the other term will be multiplied. So with that, we get this cancellation with the denominator. So 15 divided by 5 would leave us with just 3. 15 divided by 3 would leave us with 5. So what this is going to look like is we have 3 times and then this expression of x minus 4. So how that's going to look is we'll have 3 and then in parentheses, and the parentheses are really important because we want to end up distributing that 3 through. And then we have our less than or equal to symbol, and then same thing 5 times this whole expression x plus 2, so we want to be sure to use parentheses there. Now we don't have to worry about fractions. Alright, so now I'm going to simplify both sides, so I'm going to distribute the 3 and distribute the 5. So 3x minus 12 is less than or equal to 5x plus 10. And I'm going to subtract 3x from both sides. Negative 12 is less than or equal to 2x plus 10. So I'm going to subtract 10 from both sides. So I'll give me negative 22 is less than or equal to 2x. And then my last step is to divide both sides by 2. Since that's positive, I don't need to do anything special to the inequality symbol. So we're getting x is more than or equal to negative 11. So we're starting at negative 11 and including negative 11 and going off to positive infinity. So if I make a graph around negative 11 with smaller values to the left and larger values to the right, we have a solid circle at negative 11, and then we're going off to positive infinity, which is to the right. Alright, so that's solving some more complicated linear inequalities.